I'm Jonathan Mitchell. I'm an assistant professor in Earth and Space Sciences, and I have a joint appointment with Atmospheric and Oceanic Sciences as well. My main area of study is planetary atmospheres. It's sort of like doing climate science, as most people know about through global warming, but doing it in sort of different environments. My primary area has been to study Titan, which is the largest moon of Saturn. And Titan is very much like Earth's smaller cousin. It has a weather cycle, it has a climate, there's dunes and lakes and that sort of thing. Mostly I study with simulations, with numerical simulations on computers. We use these general circulation models, which are sort of atmospheres in a box. Titan's atmosphere is mostly nitrogen, so it's a lot like Earth in that sense. So the main component of Earth's atmosphere is nitrogen. And the remainder is methane, which is natural gas. It's what we use in stoves and things here on Earth. And the natural gas, the methane, is what produces the precipitation and cloud features and that sort of things in the lower atmosphere, like water does on Earth. Now, methane on Earth is produced biogenically, primarily by the decay of organic matter. So you might think that there's an organic source of the methane on Titan, and some people still hold to that. But there are also other ways to produce it without having life around. Just having lots of water in contact with rock. There are a number of different pathways for producing methane that way. If you were to observe Earth from afar, you would see methane in the absorption features in the infrared spectrum. But you would also see lots of oxygen around. And the problem with having both of those together is that methane is reducing and oxygen is oxidating. And they're very reactive with one another. So the lifetime of methane is very short in Earth's atmosphere because of the presence of oxygen. And also it gets converted by other means as well. But so if you see sort of a steady or quasi-steady level of methane in an oxygen-rich atmosphere, then that's pretty much a smoking gun for life, or vice versa. You know, the two of them together are in disequilibrium, is what we say. You can derive the abundance just from measuring the light coming from it in the infrared, and then just ask the question: would you expect this in equilibrium, chemical equilibrium? And for Earth, the answer is no. Titan is different because there's no oxygen, or not much of it anyway, in the atmosphere. So it can sustain a lot of reducing molecules like methane.